Hello everyone, in this video we are going to solve absolute value inequalities. So we can write absolute value inequalities as compound inequalities. But how do we go about solving these? Because it's a little bit different than dealing with absolute value equations. And the answer to that is it depends on which inequality symbol we're dealing with. We'll look at the greater than option first, and then we'll look at the less than, because there's two different instances. So going back to this notation, remember that capital A is going to be some variable expression. It's going to be a combination of terms separated by addition or subtraction. B here is going to be any number that is positive, because remember, we can't have anything negative over here. What we're going to have is two inequalities. It's going to be a little bit similar to what we were doing in the last video. We're going to be solving for two inequalities. But this is what's different. We're going to have whatever's here, same exact thing without the absolute value signs, and then we're going to have or the absolute value expression, whatever was in there, and then less than the negative of whatever was here, whatever number was here. So this is the instance for when we're dealing with the greater than symbol. And this will also account for if we had the inclusion one as well, the greater than or equal to. So these two will work together. What about when it's less than? Because this one's a little bit different. Whenever you have your variable expression in the absolute value symbol less than a positive number, you're going to solve the compound inequality as such. And you'll work from there. You'll solve it, and then whatever you get for the negative and the positive of whatever number this is, you can graph it on a number line to make it look a little bit, make a little bit more sense. But again, this is dealing with the less than as well as the less than or equal to inclusion. Let's look at the same example, but with the two different inequality signs. We'll work with the less than option first here on the left. So remember, with less than, what we're going to do is we're going to set it in between the positive and the negative of whatever number this is, and then solve it as one inequality. Add 1 to every part. So our solution set is going to be exclusively any number between -2 and +4. Here's -2, and I'll just write 4 up here. This is the exclusion, so we'll have open circles. And then our solution will be anything in between -2 and 4 exclusively. Because remember, we're looking at 3 units from 1. 3 units to the right, as well as 3 units to the left. I was just drawing this down here. So 3 units to the left and 3 units to the right of 1. So let's now look at the same expression, but with the other symbol. Now we have the absolute value of n-1 greater than 3. We'll have n-1 is greater than 3, but then we also have to account for the negative of this. So we'll have n-1 is less than -3. Add 1. we'll have n is greater than 4, and then adding 1 here, we'll have n is less than negative 2. And this one is a completely different solution set. So here we have negative 2, here we have 4. Open circles again, but this time it's going to be the opposite directions. So greater than 4 and less than negative 2. So we'll look at a couple of more examples in another video. This just gives you the rundown for solving absolute value inequalities and how to approach them depending upon which inequality symbol you're given, whether it's less than or greater than. Thank you so much for watching, and I will see you later.